So in this video, we'll look at how to find the normal eigenvector. So dalam video ini, kita akan cuba cari normal eigenvector. So here is the formula. So normal eigenvector is equals to the eigenvector divided by the magnitude of eigenvector. So formula dia adalah normal eigenvector adalah sama dengan eigenvector bahagi dengan magnitude of the eigenvector. Magnitude untuk eigenvector tersebut. So V adalah eigenvector. So magnitude of V, so macam mana nak cari magnitude of V? Setiap elemen dalam eigenvector tu kita kuasa duakan dia. Punca kuasa 2, X1 kuasa 2, X2 kuasa 2, X3 kuasa 2. So in order to find the normal eigenvector, so first you need to get the eigenvalue. Untuk nak cari normal eigenvector, first kita kena cari eigenvalue dulu. After you find the eigenvalue, and then you have to find the eigenvector. Eigenvector and the magnitude of the eigenvector. Then barulah kita boleh buat normal eigenvector. Normal eigenvector. So in order, this is C. In order to find the normal eigenvector, pertama sekali, first we need to find the eigenvalue. Then we have to find the eigenvector and the magnitude of the eigenvector. Then finally, we can find the normal eigenvector. So we have 3 steps in order to find the normal eigenvector. And we will use this formula for the normal eigenvector. Let's look at one example. Let's say I use exercise 4 as our example. So first, show that the characteristic equation is given as this one. So what is the characteristic equation? So let's say A. So A. First, what is characteristic equation? So characteristic equation is determinants of A minus lambda I is equals to 0. So the characteristic equation is the determinants of A minus lambda I is equals to 0. So first, we try to find what is A minus lambda I before we try to find the determinants. So where A is given, so the matrix is given. So A is given as 3, 0, negative 2, 0, 8, positive 2, 0, negative 3, and 1. So this is given minus lambda. I is our identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. And we try to simplify this matrix. So we have 3, 0, negative 2, 0, 8, 2, 0, negative 3, and 1. Minus, multiply this lambda into the identity matrix. I should have lambda 0, 0, 0, lambda 0, 0, 0, lambda. Actually, based on this one, our lambda is K. For this particular question, our K is represent as lambda. So this is the lambda. So from here, I should have 3 minus lambda will be 3 minus lambda, 0, negative 2, 0. Here we have 8 minus lambda, 2, 0, negative 3, and 1 minus lambda. So this is our A minus lambda I. Then we try to find, then we let the determinants of A minus lambda I equals to 0. So we try to find the value of the lambda. In order to find the determinant, so this is the determinants. We have two methods. One is cofactor expansion. Another one is by using the Soros formula. So where I prefer cofactor expansion. So for cofactor expansion, you have to be careful with the sign. Positive, negative, positive, negative, positive, negative, and then positive, negative, positive. You have to follow the sign. So, and I personally will choose column, the first column. Why? Because these both entries are 0. So it's easier. When any value multiplied by 0, it will become 0. That's why I've choose the first column. So now I try to find this value. First, start with positive. Positive. And then here we have 3 minus lambda. Put a bracket. 3 minus lambda. And then close the first row and the first column. So we will have this 2 by 2 square matrix, which is 8 minus lambda, positive 2, negative 3, and 1 minus lambda. So here we should have 8 minus lambda, 2, negative 3, 1 minus lambda. This is the first one. And then the second value is 0. Let's say I try to write. The second one is negative. And then let's say put here is 0. Again, for this one is close the first column and the second row. So what we have here is 0, negative 2, negative 3, and 1 minus lambda. 0, negative 2, negative 3, and 1 minus lambda. Final value is a positive. So it's a positive against 0. So now is close the first column and the third row. So what we have here is 0, negative 2, 8 minus lambda, and positive 2. So here we should have 0, negative 2, 8 minus lambda, and positive 2. And this is equals to 0. So this part, we will get 0. We just concentrate on the first part of this one. So here is 3 minus lambda in a square bracket. 8 minus lambda times 1 minus lambda. Minus 2 times negative 3. This one, 0 multiplied by any value, we should get 0. Minus 0 plus 0. That's why I choose the first column, because here we should get 0. So this part, 3 minus lambda. So here I try to expand. How are we going to expand for this one? 8 times 1, 8 times negative lambda. After that, negative lambda times 1, negative lambda times negative lambda. So here we will have 8 times 1 is 8. 8 times negative lambda is negative 8 lambda. Negative lambda times 1 is negative lambda. Negative lambda times negative lambda is positive lambda squared. Negative 2 times negative 3 is negative, will become positive 6 is equals to 0. I try to simplify this part. 3 minus lambda. Here is lambda squared. Here I have negative 9 lambda plus 14 is equals to 0. So from here, 3 minus lambda. This is quadratic equation. So we can factorize lambda minus 7, lambda minus 2. So here is our characteristic equation, which is same as this one. 3 minus k minus 7, k minus 2 is equals to 0. So therefore, I change lambda into k. So therefore, 3 minus k minus 7, and k minus 2 is equals to 0. So here is the first answer, the answer for the first question. So here is our k. So show that the characteristic equation is this one, is given as this one. So here is what we get. And then calculate the normal eigenvector using k is equals to 2. So this question mentioned is by using k is equals to 2. So actually our eigenvalue from the characteristic equation, we can get our eigenvalue. How? Just let 3 minus k is equals to 0. So 3 is equals to k. So the first value k is equals to 3. Next, k minus 7 is equals to 0. K is equals to 7. And finally, k minus 2 is equals to 0. K is 2. So this one is known as our eigenvalue. Actually, we have three eigenvalue. For this case, we have three eigenvalue. But for this particular question, it's mentioned that we are using k is equals to 2. Soalan ni dia minta kita guna k sama dengan 2. So we choose k is equals to 2. This is our eigenvalue. Like I mentioned before, in order to find the normal eigenvector, macam saya sebut sebelum ni, nak dapat normal eigenvector, pertama sekali kita kena dapatkan eigenvector dulu. Kemudian cari dia punya magnitude, then we apply the formula. So, by using this one, first we try to find the eigenvector. So, here, let's say, let's say here is B. K is equals to 2. By using the value of K is equals to 2. Next, we try to find the eigenvector. Seterusnya, kita cuba cari eigenvector dulu. So first, how we going to find the eigenvector? So substitute K is equals to 2 into this function. A minus lambda I. Ganti dalam sini. What is our A minus lambda I? This is our A, inilah. This is our A lambda I. Here is our A lambda I. A minus lambda I. Yeah. So ganti kat sini. So our A minus lambda I now will be equals to 3 minus lambda. So 3 minus 2, I put a bracket. 0, negative 2. Here is 0. 8 minus lambda, 8 minus 2, 2. And then 0, negative 3. 1 minus lambda, 1 minus 2. Simplify. Here we should have 1, 0, negative 2, 0, 6, positive 2, 0, negative 3, and negative 1. So this is the first step. Substitute k is equals to 2 into a minus lambda I. And then second, what should we do is let a minus lambda I times the eigenvector v is equals to 0. So which means that here we should have 1, 0, negative 2, 0, 6, 2, 0, negative 3, negative 1. Our eigenvector is x1, x2, and x3. and this is equals to 0, a 0 vector, 0, 0 and 0. This is a second step. Third step, transform into augmented matrix. We transform into augmented matrix, which means that from here we should have 1, 0, negative 2, 0, 6, positive 2, 0, negative 3, negative 1, 0, 0, 0. Here is our augmented matrix. So from this augmented matrix, we will step number 4, perform ERO, elementary row operation, to obtain row echelon form, REF. So we will do ERO in order to get the row echelon form. So again, I rewrite this one. Let's say here is 1, 0, negative 2, 0, 6, 2, 0, negative 3, and negative 1. Here is 0. So you can clearly see that in the first column. So the first column ni dah dalam bentuk yang kita perlukan dah. So we can go to the next column, the second column. So first column ni dah elok dah, 1, 0, 0. This is what we need. So ini apa yang kita nak. So we can move to the second column where this value suppose will become 1. Kita nak jadikan dia 1. Macam mana nak jadikan dia 1? So what we do is row number 2 we divide by 6 supaya dia jadi 1. So it will become 1, 0, negative 2. Here is 0. This part will become 0 divided by 6 is 0 lah. 6 divided by 6 is 1. 2 divided by 6 is 1 over 3. And then here is 0. Third row, unchanged. Next, here suppose is 0. Bawah ni sepatutnya kosong. So how we going to get 0? By using R2. Since here is negative 3, we multiply this with positive 3 plus row 3. Then here we should get 0. Kita sepatutnya dapat kosong. Unchanged for the first and second row. So I rewrite first and second row. Now here is the third row. Here must be 0 lah. 0 times 3 plus 0, 0 lah. 1 times 3 is 3. Plus negative 3, here is 0. So kita memang nak dia kosong. Let's say yang ni I show you. 1 over 3 times 3 plus negative 1. Plus negative 1. So here is 1 over 3 times 3 is 1. Plus negative 1 is equals to 0. Kebetulan sini 0. Bukan tiap-tiap kali 0 Kebetulan this is 0. So 0 times 3 is 0. Plus 0 is 0. So here is our row echelon form. This is the row echelon form. Kita stop kat sini. This is the row echelon form. So by using back substitution, let's say here is the first row. First row. Here is the second row. So we start with the second row. Kita mula dengan second row. The first column is x1. Here is x2. Here is x3. We start with the second row. Back substitution. Using back substitution, 1, x2, 0 means x1 does not exist lah sebab 0. So 1 x2 means that x2 plus this is positive 1 over 3. So plus 1 over 3 x cubed is equals to 0. So next I move this one to the right hand side. X2 is equals to negative 1 over 3 x3. So next we just kita hanya let x3 is equals to t. Then kita punya x2 suppose is equals to negative 1 over 3 t. So kita dah ada x3 and x2. x3 is t, x2 is negative 1 over 3t. So now we find the x1. So by using the first row, 1x1, so means that is x1, plus 0x2. x2 is not exist. So minus 2x cubed is equals to 0. So x1 is equals to, against I move negative 2x cubed to the right hand side, I should get positive 2x cubed. So against our x cubed is t. X cubed kita, x3 kita adalah t. So x1 will be equals to 2t. So based on this one, our eigenvector. So kita dah dapat eigenvector, which is equals to x1, x2, x3. And we found that our x1 is 2t, x2 is negative 1 over 3t, and x3 is t. So inilah eigenvector kita. So like I mentioned before, in order to get the normal eigenvector, first we need to eigenvalue. Kita dah ada dah. Then kita cari eigenvector. Next is the magnitude. Magnitude of eigenvector. The symbol magnitude of eigenvector. The formula is square root of x1 squared plus x2 squared plus x3 squared. Then what is our x1, x2, x3? So inilah x1, x2, x3 kita. x1, x2, x3. Just substitute into the formula. Square root. x1 is 2t. Jangan lupa put a bracket. Plus negative 1 over 3t plus t squared. So here we should have, that's why you kena letak kurungan. Kita akan dapat 4t squared. Plus this one, negative 1 over 3 squared. Negative 1/3 bila kita kuasa 2 akan jadi positif 1/9 t squared plus t squared. So by using a formula, 4t plus t is 4t squared plus t squared is 5t squared. So I just put 5 plus 1 over 9. This one, 46 over 9 t squared. So we try to simplify this part. Kita cuba ringkaskan. So we should have square root 46 over square root of 9. And then here we should have square root of t squared. Based on this one, we should have square root of 46 over 3. Here is t. So this is our magnitude of eigenvector. Finally, therefore, finally, normal eigenvector, the formula is V eigenvector divided by the magnitude of the eigenvector. So where our eigenvector, so I can put in this way. So let's say I put this way. Our eigenvector will be 2t negative 1 over 3t and T. Ini eigenvector kita. This is our eigenvector. Divide by the magnitude. Magnitude is square root of 46 over 3T. So I can write in this way. 2T negative 1 over 3T T per. So this one I could boleh tulis sebagai square root of 46 T tulis kat tepi ni over 3. Bila kita darab naik atas. And then if I move to the numerator, bila kita pindah ke atas, dia akan jadi 3 over square root of 46T times, dia bukan dalam square root ni, dia kat tepi ni, 2T negative 1 over 3T and T. So this T we can simplify. So we should get 1 here. So finally, our normal eigenvector is 2, negative 1 over 3 and 1. Nak darab masuk pun boleh. Or you can just left your answer in this form. You can multiply into the vector or you can left your answer in this form. So this is how we're going to find the normal eigenvector. So bear in mind, in order to find the normal eigenvector, untuk nak cari normal eigenvector, so first we need to find the eigenvalue. Kita kena cari eigenvalue dulu. Dan in this question, eigenvalue is not given, but we try to show. Dia minta kita tunjukkan kita punya characteristic equation. So this is our eigenvalue. Sorry, excuse me. So this is our eigenvalue. So from this eigenvalue, and the question will mention by using k is equals to 2 ke or the smallest value. The question will definitely mention what value eigenvalue that we're going to use. Dia akan mention, jangan risau. So this one, inilah cara kita lepas cari eigenvalue, kita kena cari eigenvector. So substitute this one lah. For this particular question, we are using k is equals to 2. So this is how we're going to find the eigenvector. So you see, from this part, we get the eigenvector. And then we find the magnitude. So this is the magnitude. Finally, the normal eigenvector. So this is how we find the normal eigenvector. So in this video, what we're going to do is what we're going to learn is to find the normal eigenvector. So again, you need the eigenvalues, and then you need to find the eigenvector and the magnitude of the eigenvector, and finally use the formula for the normal eigenvector. So that's all for this video.